Let's practice graphing a sine function that has some stretch transformations together. If you're relatively new to graphing trig functions and you want to see a video on just graphing the parent function or just graphing a sine function that has some vertical or horizontal translations, feel free to check out one of my other videos where I go through those ones as well. And if you'd like to download a free copy of this PDF, you can find a link in the description box below, as well as an annotated answer key of the completed worksheet from this video. Let's jump right into it. For this function, we have f of x is equal to 3 times sine of 1/2 of x. And as usual, we want to figure out what our values of a, b, c, and d are because they're going to let us know what kind of transformations we're going to have on the parent function. So let's see here, let's go ahead and write it out super clearly. So we have f of x is equal to, it looks like our a value is going to be 3. So we're going to do 3 multiplied by sine of, let's go ahead and open up some brackets here. It's going to be sine of what? Well, we have a b value here. In this case, we have this 1/2, and that's going to be multiplied by this x. And that's it. We're also going to have a minus 0, right? Because we don't seem to have anything being added or subtracted inside here. So let's go ahead and close that parentheses and put the brackets here. And then we're going to add d. Looks like we also don't have anything out there, so we're going to write plus 0. Hopefully writing this out like this will help you identify your a, b, c, and d a little bit more clearly. So we can see here that a is equal to 3. So I'm going to go ahead and write that in over here. We can also see that b is equal to 1/2. I'm going to go ahead and write that in for b. For c, we have 0, so let's go ahead and write 0 for c. And then for d, looks like we have 0 as well, so we can go ahead and write that. Because c is equal to 0, we're not going to have any horizontal translation, so the graph's not going to move left or right. And then because d is equal to 0, we're not going to have any vertical translation, so the graph's not going to move up or down. To know whether we have a vertical reflection or not, or flip across the x-axis, that is going to be dependent on basically just the value of a, if it's going to be positive or negative. But you can see here that a is a positive value, so we're not going to have any reflections here. We'll save that for another video. As for the horizontal reflection, or flip across the y-axis, that's going to be dependent on the value of b, and if b was negative. So we can see here that b is a positive value, so we're also not going to have any reflections. So we'll save that for another video. The amplitude is going to be how high or how low this graph is going to be moving. So that is dependent on the a value here, and that's going to be 3. So our amplitude for this sine function is going to be 3. Basically, our graph is going to move 3 times higher than normal and 3 times lower than normal. Then, of course, we have our period, which is typically just equal to 2 pi because it's 2 pi divided by 1. But in this case, we have a b value of 1/2, right? So for this formula, this is going to be 2 pi, but we're going to divide this by b. And in this case, we can see that b is going to be equal to 1/2 here, right? So if we take 2 pi and we divide that by 1/2, we can rewrite this as 2 pi, and we're going to divide that by 1/2. So I'm just writing this out from left to right. And when we divide, keep in mind that we multiply by the reciprocal. So 2 pi is going to multiply by 2 because that's the reciprocal. And so 2 pi times 2, that is 4 pi. So to complete one whole cycle here, the period for this trig function or this sine wave is going to be 4 pi. So it's twice as long as usual. Now sometimes it may be a little confusing, but on the x-axis, they're just written by normal numbers, not in terms of pi. So if you're looking on a number line, this should be roughly 12.56, and that's where you'd be on the x-axis when you complete a cycle, or the distance between them. Next, we have our midline, and that's affected by the value of d. But since d is equal to 0, then a midline is not going to move at all. So we're going to say it's y equals 0. Now, what about the minimum y value, or the lowest part of this graph? The minimum is going to occur when we take the midline value, which is going to be 0, and we take away the amplitude. So 0 minus 3, that's going to equal -3. So that's going to be the minimum y value in this particular problem. And then for our maximum y value, that's going to be our midline plus the amplitude. So the midline is 0, adding on the amplitude of 3, 0 plus 3, that's going to equal 3. So the highest y value we're going to have for this graph is going to be +3. All right, now that we have all those kind of background bits of information out of the way, let's go ahead and see if we can get some tables and some graphs together. Just like in the last video, I'm going to go ahead and use this table here to write the 5 important points of the parent function, and then we're going to transform them over here to the particular 5 points we need for this function. All right, so it's good to refresh the parent function to make sure you have this memorized. But basically for the parent function, the sine wave always starts at the origin. It comes up to +1, hits the x-axis, goes down to -1, then comes back up to the x-axis. So this is going to be one full period. And the parent function, again, starts at 0, 0. And then after pi over 2, it comes up to +1. where it maxes out its y value, it comes back to the x-axis. Then over here, it's going to go down to -1 and it goes back to 0, right? So in a period of 2 pi, it's going to complete 1 cycle. That's the parent function. So the parent function starts at 0, it ends at 2 pi. Halfway through would be pi. Half of that is going to be half a pi, or pi over 2. And then between pi and 2 pi, that's going to be 3 pi over 2, right? We also know that for the parent function, it starts at the origin, it goes up to +1, goes back to 0, goes down to -1, and goes back to 0. So what about this function? Well, the original parent function has a period of 2 pi, but in this particular problem, we have a period of 4 pi. We don't have any horizontal translation, so we're going to start at 0 still, and then end at 4 pi, right? So that's why it's important to know the period. So that means that in the middle of 0 and 4 pi, we're going to have 2 pi. Between 0 and 2 pi, we're going to have 1 pi. And then between 2 pi and 4 pi, we're going to have 3 pi. Now that we know it's going to start at 0, it's going to end at 4 pi, and you can write this in earlier if you want to. I'm just kind of doing it in this particular order, so whatever floats your boat is perfectly fine as long as this information makes sense to you. All right, so that's going to be our 5 markers for where we have some important things happening, our intercepts, okay, as well as our min and max values. Now, what about our f of x value? So these are going to be the y values. Well, typically for the parent function, we know it starts at the origin, then it goes up and then back to the x-axis, then down, then back to the x-axis. But again, we have an amplitude of 3 here, and that's going to be basically multiplying each of these y values over here by 3. So everything's going to move 3 times further, right? Well, 3 times the 0 is going to still be the 0 here, okay? So again, 3 times the 0 is still going to be 0. Then if we multiply 3 times this 1 here, that's going to end up being 3, so it's going 3 times higher. Then we're going to take this 3 times 0, that's still going to be 0. Then take this 3 and multiply it by -1, that's going to be -3, so it's going 3 times lower. And then take this 3 and multiply by 0 again, and that's going to be back on the x-axis. You can think about this 1/2 over here for the value of b kind of basically affecting the period, and this is causing a horizontal stretch. So you can see that while the typical period was 2 pi, now it is 4 pi. So it's taking twice as long to complete 1 cycle. And then our a value here of 3 basically is taking our whole function and multiplying it by 3. So the output, or the y values, are going to be 3 times higher than usual. So this is what we call a vertical stretch. So the whole graph is going to go higher and lower than usual. So even if you just want to draw a rough sketch, you would know that the same thing is going to happen as the parent function, but it's going to go 3 times higher and 3 times lower, and take twice as long to complete a cycle. Now that we got all the hard work out of the way, let's go ahead and make our graph. Now feel free to scale your graph however you would like to. In previous videos, I've scaled by maybe half a pi per each tick mark, or even a quarter of a pi. In this particular video, I'm just going to scale by 1 pi. So even though that we are having a horizontal stretch, which means it should be stretched out a little bit more, it's not necessarily going to look like that here, because again, I'm scaling by 1 whole pi for each tick mark, whereas you may see that normally being just by 1/4 of a pi or half a pi. For a y-axis, I'm just going to go from 1 to 2 to 3. I guess I'll put a 4 here, but it's not necessary. I'll put a -1, -2, -3, and -4. So I'm just going to go by 1s along the y-axis. 0, 0 is going to be located at the origin right over here. Pi, 3, that's going to go to the right pi and then up 3 units. That's all the way up here. 2 pi, 0 is next. That's going to be to the right 2 pi, and it's going to be on the x-axis. 3 pi, -3, it's going to go to the right 3 pi and then down to -3. And then finally we have this 4 pi, 0, so to the right 4 pi and then stay on the x-axis. So this is going to be one period of our function, and this is going to be a rough sketch of this curve. And if you have to show more of these periods, you can continue with 5 pi, 6 pi, 7 pi, and 8 pi to the right. And then continue writing your x values to the left over on the left side of the x-axis. Then you can continue plotting points following the pattern that we've already created. So just continue that same pattern, go up, then go back to the x-axis, go down, and then back to the x-axis. This would be a continuation of that sketch to the right. And then you can continue that pattern to the left of this by going down, back to the x-axis, go above the x-axis, back to the x-axis, below 3, back to the x-axis, above 3, and then back to the x-axis. Trying to draw a smooth curve, this is what the continuation of this would look like over additional periods. Here on the x-axis, we'd have our midline at y is equal to 0. Then you can see our maximum y value is up here at positive 3. Our minimum y value is down here at negative 3. And you can see that our amplitude of 3 basically tells us that we have a distance of 3 moving up here from the midline to the positive or highest y value in this case. And then our midline down to the minimum y value is going to be down 3 because our amplitude is 3. So it's 3 up and 3 down. Hopefully you can see the vertical stretch pretty clearly here going up to 3 and down to negative 3, but the horizontal stretch is a little bit trickier to notice. While the vertical stretch is a little bit easier to see here because we're going all the way up to 3 and then we're also going all the way down to negative 3, the horizontal stretch is a little bit harder to see here. Now notice how one whole period takes 4 pi, but remember the parent function is only having a period of 2 pi. So if you look at this at scale, then the parent function would actually look like this, where it would start the origin, go up here. At pi, it's going to be at 0, then go down, then back up to 2 pi. So the parent function would look just like this on the scale that we have on the graph here. So hopefully you can see that it does go 3 times higher and lower because of that amplitude change here of 3. And then also we can see that it has scaled twice as further along the x-axis. So instead of ending at 2 pi, it ends at 4 pi. So hopefully you found this video helpful in understanding how to graph these types of stretches, these types of transformations. If you found the video helpful, please consider giving it a thumbs up and sharing with a friend that might find it helpful. And you can also find a link with all of this in the description if you want to download it and check it out as well. And as always, keep up the great work that you're already doing, and I'll see you in the next one.